Okay, so good morning, one and all. Today is the 14th of September. We are starting the 23rd lecture. So, this is the seventh lecture in module 3, and so far we have completed three topics mainly in module 3. So, module 3 is having actually four topics. The first one was the RC and RL, impulse response and step response. Then, second topic was RLC system, that is a second order system step response, and then numerical. Third topic, in the previous 2 days we have completed, that is steady state error estimation. So there are three systems: type 0, type 1, type 2, and for each of them we are applying three inputs, that is unit step input, ramp input, parabolic input. We have to estimate how much is the system error. So after these three topics, then there is the pole zero concept. So pole zero concept we can see in the next chapter. So actually I have explained to you, because whenever there is a transfer function, there is a numerator polynomial, there is a denominator polynomial. So numerator polynomial, if you are finding the roots, that is called as zeros. So roots of numerator polynomial is called as zeros, and roots of denominator polynomial, they are called as poles. And as per the stability condition is there for any system, poles of the system should be in the left hand side of S plane. Then only the system is going to be stable. So if there are 10 poles in a system, so it's a 10th order system. That means denominator equation will start with s raised to 10 plus coefficient s raised to 9 plus coefficient s raised to 8, and accordingly. That means there are 10 poles. All the poles, if they are in the left hand side of S plane, then we call that the system is stable. What is meant by system is stable? System is stable means whatever is the response of the system, that is output of the system, that is going to produce a finite area with the x-axis and y-axis. That means area under the curve, response curve, will be finite. So we have seen the energy function and power. So energy system, power system, energy function, power. So if it's a energy signal means if we are seeing that this is the x-axis, the y-axis, and there is a line like this, which is starting from the y-axis and touching the x-axis. So it forms a triangle kind of thing. So x-axis, y-axis, and that curve actually is producing a closed area. So closed area means we can calculate how much is the area, and in that case, the system would be called as a finite area system, or that system will be called as, or that signal will be called as energy signal. So all those fundamentals we will check. So this is all about system stability analysis, whether the signal is having a bounded area or unbounded area. So bounded area is always giving us a stable function. What does this fourth topic doing? So Routh-Hurwitz criterion, what is this doing? So this is a criteria which is actually helping us to find out whether the system characteristic equation is having a stable function or an unstable function. That means whenever we are finding CS by RS, so from that CS by RS, we are finding the denominator equation, that is a denominator polynomial in transfer function, that equal to 0 is called as a characteristic equation. Now, whenever we are finding that kind of equation, that is characteristic equation of a system, from there we can find out whether the system is stable or unstable. That means this is a criterion, Routh-Hurwitz criterion. This actually tells us whether all the roots of the characteristic equation are in the left hand side, or there are some roots which are lying in the right hand side. So I was just giving the example of a system of order 10. So even if the system is having order 10, so there are 10 poles. In that case, if suppose 9 pole is there in the left hand side of S plane and 1 pole is there in the right hand side of S plane, then also the system will become unstable. So for the system to be stable, all means all of its poles should be in the left hand side of S plane. If one of the pole is there on the j omega axis, that is j omega axis is actually dividing the whole S plane into two parts. Left hand side of the S plane is for stable pole, right hand side of the S plane is called the unstable poles. What if the poles are on the j omega axis? So whenever the poles are on the j omega axis, we call it marginally stable pole. Okay, that is we don't design a system with marginally stable pole, because marginally stable pole is almost like unstable pole. Okay, it is not unstable, but we don't design marginally stable. That means वो कभी भी इधर उधर जा सकता है. We don't design that. So we always design system with pole deep into the left hand side of S plane. Okay, so there are three cases possible with the pole position. Left hand side of the pole, that means real part of the pole is negative, that is the stable poles. Real part of the pole is positive, that means poles are situated in the right hand side of S plane, it is called as unstable pole. And real part of the pole is equal to 0. Okay, so in that case the pole will be on j omega axis. That system is called as a marginally stable or critically stable pole. Likewise, RH criterion tells us about or gives us very easily, or it helps us to find out whether the system is having left hand side pole, right hand side pole, or marginally stable pole. So there are mainly three kinds of numericals. So I will just remove this document and I will upload my document, which is handwritten, and there everything about Routh-Hurwitz criteria is very clearly explained. So let me launch my handwritten note, and this is actually can be found out from the book of M. Gopal, and this is there at page number 222. And in the book of M. Gopal, which is already uploaded, so I think very initial part of this Google Classroom, you will be find that I have uploaded the book PDF, and in that book PDF, page number 222, you will be finding the Routh-Hurwitz criteria. I think my notes is visible to you, so I have just uploaded the control system. Module 4 it is given, it is actually not module 4 for your syllabus, it is actually module 3. Okay. So this is lecture number 23. Let me make the changes. So this is lecture number 23, control system fast track, so that also I should say. So this is fast track, like this. Okay. And let us go through this whole document, and here mainly we are going to solve numerical. So this initial parts you can read from the book of M. Gopal, page number 222. So I have given you all these basics, that is what is a transfer function Cs by Rs, what is a characteristic equation, there is a denominator polynomial is equal to 0 is called as a characteristic equation, and we are trying to find out whether the poles of those characteristic equations are lying in the left hand side or right hand side. So let us directly jump into a numerical, okay, and understand the concept of Routh-Hurwitz criterion from it. And those who are attending the lectures, to tell them there are mainly two questions which can be asked from this Routh-Hurwitz criterion. In short, we call it RH criterion. Okay, as per the name of the inventors who had invented this method of stability analysis for any closed loop system. So the one is Routh, another is Hurwitz. So as per their name, this criteria is called as the RH criteria. So what should be given? Given to you will be the Cs by Rs characteristic equation or denominator equation. One equation will be given to you. What is this equation? S is to 4 plus 8s cube or something. Okay. So I guess my note is visible to you. Okay. Okay. What is given to us? Given to us will be the characteristic equation. Characteristic equation means this s is to 4 plus 8s cube plus 18s square plus 16s plus 5. What is this? This is there at the denominator of Cs by Rs. Okay. So this kind of a equation will be given to you, and from there you are supposed to design the RH table. Okay. And this is how RH table is designed. I will tell you how to design this and what are the steps. So this is a very simplest kind of a numerical. So I told you there are two types of questions possible from this, and you have to remember these equations because I might ask a theory question. Okay. So first question you can write down. First question is numerical will be given to you like this, equation will be given to you, and I will ask you find out the stability of the system. So in that case you have to do this table, and from the table you have to see the first column. Okay, so after forming the table, how to form the table I'll tell you, it's very easy. After forming the table you have to see the first column. Okay, it comes after calculation. So if you're finding there is no sign change in the first column, okay, so where this table comes from, this table comes from this above equation. After you form the table, just check the first column. If there is no sign change in the first column, no sign change in the first column means all elements in the first column are positive, or all elements in the first columns are negative. Okay, both are okay. In that case, if there is no sign change in the first column, what we come to the conclusion that there is no pole of the system which is lying in the right hand side. That means all the poles of the systems are lying in the left hand side of S plane, and the system is very stable. So you can see this numerical, they have given a characteristic equation. That means this is there at the denominator of the Cs by Rs. So s raised to 4 plus 8s cube plus 18s square plus 16s plus 5. Now you have to divide this thing into two different polynomials. One thing is called as the even part, another is called as the odd part. And what is the highest power of s? Highest power of s is s to 4. So first thing, as soon as you are given this kind of numerical, and generally the highest power, so this is a fourth order system. That means there are four energy storing element in the system, and generally we're finding that this highest power is having a coefficient generally equal to 1. Generally we find it. I'm not saying this is a rule, okay, but generally what we find is the highest power is having a coefficient is equal to 1. नहीं भी है तो भी चलेगा. Okay, so this ss24 can have a coefficient of 3, doesn't matter, but generally we find that this coefficient is equal to 1. But you have to divide the whole polynomial into two parts. One is the even part and there is the odd part. What is the even part? ss24 plus 18s square plus 5. So ss to 4 plus 18s square plus 5. So first you have to, as soon as this is ss to 4 in the table, in the left side you have to start from ss to 4, s cube, s square, ss to 1, ss to 0. So this line you have to write vertically. If I had written this is suppose ss to 5 plus 2 ss to 4 plus 8 s cube and all, if I give you a fifth order system, then you have to write here ss to 5. Okay, so it is very easy. There is nothing difficult about it. So as this is ss to 4, that means you have to start with ss to 4 and you have to write the coefficient of the even polynomial. What is the even polynomial? Ss to 4 plus 18 square plus 5. So that's what I have written: 1, 18 and 5. What is 1? 1 is the coefficient of ss to 4, 18 is the coefficient of s square, and 5 is the coefficient of ss to 0. So ss to 0 is taken to be the even polynomial. So whatever is the highest, so in this equation, even is having the highest even polynomial, ss to 4 is having the highest order. So that's what I'm starting from, ss to 4. Some numerical, maybe it will be having ss to 5. So in that case we will write the odd polynomial coefficients at the top. We will see some numerical. Okay, so this is 1, 18 and 5. Okay, so this is 1 ss to 4 plus 18 square plus 5. So 1, 18 and 5, this we have to write. And then there is odd polynomial. So s cube is having a coefficient of 8 and then 16s. So odd polynomial is 8s cube plus 16s. So that's why 8 and 16 I'm writing. And there is no other thing below this, so just you write 0. So 0 is called as a missing term because there are 3 terms at the top. That's why there should be 3 terms at the bottom also. If you don't write this 0, then also it is understood that it is 0. Up till this, is it understandable?
Yes, sir.
Okay. Now how to find the other terms? So s square, ss to 1, ss to 0. How to find this other term? Just check. How do you find determinant? So determinant is top left multiplied by bottom right minus bottom left into top right. Okay. So this is how we find determinant. यहाँ पे determinant जैसा नहीं है. Here it is minus of determinant. Okay. That means first we have to take the bottom left to top right. That means 8 into 18. This we have to write first. Okay. 8 into 18. So bottom left. So in determinant what we do is top left multiplied by bottom right minus bottom left into top right. Here we do reverse. Okay, how to find the other table parameters? So bottom left multiplied by top right, that is 8 multiplied by 18. हर जगह पे वही करना है. Everywhere below, everywhere it is there that you have to take the bottom left multiplied by top right minus top left multiplied by bottom right. So 8 into 18 minus 1 into 16 divided by the bottom left element. So bottom left 8 multiplied by top right, that is 18 minus top left 1 multiplied by bottom right. Okay, divided by the bottom left element. Okay, so 8 into 18 minus 1 into 16 by 8. इतना ही part तुमको समझना है. Okay, and for every case we have to do like this. Divided by 8 if you do, then 8 into 18 minus 1 into 16 by 8. If you do the calculation by calculator, it comes as 16. And please don't make mistake in RH criterion, because this is the easiest 8 to 10 marks or whatever marks is allotted that you can get in the whole control system exam. Easiest, because this is only very simple fifth standard arithmetic that you have to do. Okay, so this is called as 16. What is next? Next is 8 into 5 minus 1 into 0 divided by 8. So 8 into 5 minus 1 into 0. So 1 into 0, yeah, that is 0. So that means 8 into 5 divided by 8. That's why it is coming to be 5. So a square row is having two elements. One is 16. How do we get it? 8 into 18 minus 1 into 16 by 8. This is how you are getting 16. Next element is 8 into 5 minus 1 into 0 by 8. That's why you are getting 5. Okay. So this is two things. So now the table has come. It started from ss to 4. Then it has come to s cube. These two were given. This two we got from the this equation, that is characteristic equation. Then what we are finding is the s square elements. So s square elements are calculated. So now the table is 16 and 5. Okay, now how to find this s raised to 1? So it is 16 into 16. It is 16 into 16 minus 8 into 5 divided by 16. Okay, so it is 16 into 16 minus 8 into 5 divided by 16 likewise. So if we are just calculating it, it is going to be 27 by 2. 27 by 2 means 13.5. So what is the value does not matter, but whether it is positive or negative, that is of very much importance. So it is 16 into 16 minus 8 into 5 divided by 16. That means bottom left multiplied by top right minus top left multiplied by bottom right divided by the bottom left. So you can see here 16 into 16, that is this 16 and this 16, minus 8 into 5 divided by 16. If you do that, you are going to get 13.5 or 27 by 2. Okay, and the other thing is not there, so you can write it 0. Now last thing is what is remaining, 16, 5 and 27 by 5. Okay, so if you do that and 0, so this is now 27 by 16, 5, 27 by 2 and 0. So 27 by 2 is 13.5. So what is the last line? How do we got this 5? So this is 27 by 2 multiplied by 5. So last line, ये बच्चे लोग confuse हो जाते. 27 by 2 multiplied by 5 minus 16 multiplied by 0. So 16 multiplied by 0 means it is 0. That means 27 by 2 multiplied by 5 divided by 27 by 2. So that gives you the value of 5. So please, it's my request that all of you practice these numericals, whatever I am showing today, on your own. एक बार हाथ से खुद करके देखो. देख के नहीं होगा. When you start solving, if you make mistake, one mistake, positive, negative हो गया, then your whole inference or conclusion will be wrong. And if your conclusion is wrong, then you are not going to get any mark. Okay, so there is no part marking for Routh-Hurwitz criterion because it is very easy. So either you get full marks or you don't get anything. So ये सब for the 16, 5, सर एक ठीक हुआ एक मार्क दे दो, ऐसा नहीं होता है. We want the whole thing to be right. Okay, so first two lines we will get from the equation. So whatever are the even polynomial, what is the odd polynomial, their coefficient, we get the first two line in RH criterion. And I'll tell you, in the exam s raised to 7 equation with s raised to 7, that also is asked. That means the top polynomial will be having s raised to 7, s raised to 5, s raised to 3, s raised to 1. And the bottom thing will be having s raised to 6, s raised to 4, s raised to 2 and s raised to 0. So almost 7 to 8 elements will come in the first two rows. So those are very big numerical. They are also asked in the exam. Be prepared. So this is how it is. So only you solve this numerical, the same fundamental remains for all numericals. So I have explained this. So first two rows are found from the characteristic equation. Then remaining three rows, what we are finding is from the calculation. And how to do the calculation? We have to do reverse of how we find determinant. That is bottom left multiplied by top right minus top left multiplied by bottom right divided by the bottom left element. Okay, just give me 1 minute. I'll just come back. So is it understandable what the way we are supposed to proceed? If yes, then I will go for the next numerical. So it is the same numerical. You are finding that. Okay. So after that, after we have found it out, then what is the final conclusion? Just check what is the first column. Okay. What are the first column elements? So you are finding the first column element. So first you have to find the whole table. You have to form the whole table and then just check the first column element, and you have to say that all the elements in the first column are having same sign. Positive or negative, that is not important. All elements in the first column are having same sign. That means there is no sign change. That is a very big important thing. there is no sign change. That means positive, negative, positive ऐसा नहीं है. Okay, so all the elements in the first column are having same sign. That means there is no pole which are existing in the right hand side. Actual rule is the number of sign change in the first column, that is equal to the number of poles which are existing in the right side of S plane. So this is the crunch line. लिख के रखो. Number of sign change in the first column is equal to number of sign change in the first column is equal to the number of poles which are existing in the right hand side of S plane. So as there is no sign change in the first column, that means there are no poles which are existing in the right hand side of the S plane. That means there are four roots, and all the four roots are existing in the left hand side of S plane, and hence the whole system is stable. So this is what is written in the conclusion part. So the elements of the first column are all positive. All positive means all same sign. Hence the system is stable. Next numerical, if you see, this is 3s raised to 4 plus 10s cube plus 5s square plus 5s plus 2. If you're doing that, so first is 3, 5 and 2. Okay, so 3s raised to 4 plus 5s square plus 2. This is the even polynomial. That means 3, 5 and 2. And then there is 10s cube plus 5s. So 10s cube plus 5s means I have written 10 and 5. The same thing can be written as 2 and 1. So you can do some kind of division by 5 or something. Okay, so GCD, whatever thing we do, the same thing we can do. So odd polynomial is having coefficient as 10 and 5. Okay, the 10 and 5 we can write as 2 into 2 and 1. Okay, so the first row is 3, 5, 2, and second row is 2 and 1. Then what is the S square? So this is 2 into 5 minus 3 into 1. That is 10 minus 3 divided by 2. This is 7 by 2. Okay. So after you write 10 and 5, somebody wants to proceed with 10 and 5. That is also not wrong. Then also you will be getting the same conclusion. Okay. But 10 and 5, for our ease of calculation, for making the system smaller, or calculation smaller, we can make 10 and 5 as 2 and 1. So this is 2 into 5 minus 3 into 1 divided by 2. So that we are getting a 7 by 2. And next line, this is 2 into 2 minus 3 into 0 by 2. So that's why we are getting as 2. Okay. So what will be the next elements? So next element is now 2, 1, 7 by 2 and 2. Okay. So this is 2, 1, 7 by 2 and 2. How to find that? 7 by 2 into 1 minus 2 into 2 divided by 7 by 2. So this is 7 by 2 multiplied by 1. That means 7 by 2 minus 2 into 2, that is 4. So 7 by 2 minus 4 divided by 7 by 2. So this is written here, 7 by 2 multiplied by 1 minus 2 into 2 divided by 7 by 2. And you are finding that this calculation is yielding, this is minus 1 by 7. Okay. Now what are the elements? 7 by 2, 2 minus 1 by 7 and 0. If nothing is there, then 0. Then how to find it? So this is minus 1 by 7 multiplied by 2 minus 7 by 2 into 0 divided by minus 1 by 7. So what will remain here is 2. So this line again I'll tell you how to find the SS to 0. Minus 1 by 7 multiplied by 2 minus 7 by 2 into 0 divided by minus 1 by 7. That means only this 2 will come here. So in this case, you can see what is written below. It may be noted that in order to simplify the computational work, S cube row in the formation of the Routh array has been divided by 5. So whatever is done at the top, that is being explained here. Examining the first column. So this is what you have to write in the conclusion, and you have to very clearly explain it. So just don't say stable or unstable. Why it is stable, why it is unstable, that logic you have to give. Okay, so exactly the way it is written here, exactly the same way you have to write. Examining the first column of the Routh array, it is found that there are two changes in sign. Two changes in sign kaise ho gaya? So first element is 3, second element is 2, third element is 7 by 2. Fourth element is minus 1 by 7. So first change is 7 by 2 to minus 1 by 7. This is one sign change. And second change is minus 1 by 7 to 2. So positive. So first 7 by 2 to minus 1 by 7. That means positive to negative. This is the first sign change. And then minus 1 by 7 to 2. That means negative to positive. This is second sign change. So what we have to say is, examining the first column of the Routh array, it is found that there are two changes in sign. From 7 by 2 to minus 1 by 7, and from minus 1 by 7 to 2. So therefore the system under consideration is unstable with two poles in the right hand side of S plane. So this is a characteristic equation which is having its 3s raised to 4. 3s raised to 4 means s raised to 4, that means it's a fourth order closed loop system. And fourth order closed loop system means there are four poles, and in four poles we are finding that two poles are lying in the right hand side of S plane. That means two poles are in the left hand side of S plane. So as two poles are in the right hand side of S plane, I told you that even if there is one pole in the right hand side of S plane, system becomes unstable. Why there are two poles in the right hand side of S plane? Because there are two sign changes. So this is the logic you have to give. That is, there are two sign changes. That means there are two poles in the right hand side of S plane, right half of S plane, that is RHS of S plane, and therefore the system under consideration is unstable. Okay, so this is how we are supposed to find out the stability of a system by using RH criteria. This is a big numerical. Okay, so I told you that there are ss to 7, ss to 6. Those numericals also can be asked. So let us find the system stability by RH criteria, and you can find here that there is a negative in the first column, and from so 3 to minus 38 by 5 there is a sign change, and minus 38 by 15 up to 4 there is another sign change. So out of the six poles, there are two poles which will be there in the right hand side of S plane. So how to form the table, that already explained. So here again you have to divide the whole characteristic equation into two parts. So characteristic equation is nothing but the denominator of Cs by Rs. So in this case, s to 6 plus 4s 5 plus 3s to 4 plus 2s cube plus s square plus 4s plus 4, that equal to 0 is the characteristic equation. So divide into even part and odd part. So what is the even part? S to 6, that means 1 is the coefficient. 3 s to 4, that's why this is 3. And 1 s square, that is 1, and 4 s to 0. So that s to 0 is also a part of the even polynomial. So 1, 3, 1 and 4. 1, 3, 1 and 4, this is the first line. And second line is 4s to 5 plus 2s cube plus 4s. So 4 2 4. If you are keeping 4 to 4 and proceeding, then also you are going to get it correct. But 4 to 4 I can divide by 2, and I can make the second line as 2 1 2. And then again the same thing, the bottom left multiplied by top right, that is 3 into 2, that is 6, minus 1 divided by 2. So first element is 5 by 2. Second element is 2 into 1 minus 1 into 2 divided by 2, so that is 0. Third element is 2 into 4 minus 1 into 0 by 2. The third element is 4. Okay. Then how to find the s cube? So this is 5 by 2 minus 1 divided by 5 by 2. So first element is 1. Then 5 by 2 into 2. That means 5 minus 2 into 4, 8 divided by 5 by 2. So this we are finding as minus 6 by 5. Anything happens in the second column is not affecting the stability. We have to see only the first column. So this is how s cube is found. Same way the s square is found. Same way s to 1 or s to 0. All these things are same. Okay. How to find s to 0? Student get confused. So how to find s to 0? So if you have found up to s to 1, then this minus 38 by 15 multiplied by 4 minus 3 into 0 divided by minus 38 by 15. That is minus 38 by 15 into 4 divided by minus 38 by 15. So that gives us 4. What is the conclusion? Conclusion is we have to check the whole first column, only the first column elements, nothing else. Okay, so if in the first column element there are sign change and there are two sign changes. So sign changes means 1 2 5 by 2 1 3. Up till this all were positive, no problem. After that it is suddenly coming to minus 38 by 15, and there's the first sign change, and second sign change is minus 38 by 15 to 4. So whenever we are finding this kind of thing, there are two sign changes. That means there are two poles out of 6 which will lie in the right hand side of this plane. Hence the system is going to be unstable. So that's why it is written as, it is seen that the polynomial has right hand plane roots, because there are two roots which are in the right hand side of this plane, because there are two sign changes. Since the element of the first column are not all positive. All positive means not all are of same sign. So there are two sign changes. In fact, there are two roots in the right hand side of plane, since there are two sign changes. Okay, so if the first column are all negatives, then also the system is stable. Okay, so all elements in the first column are negative. चलता है, positive ही होना है ऐसा नहीं है, but there should not be any sign changes. So all elements in the first column are negative. Is the system stable? Answer is yes, because there is no sign change. So we will not see whether it is positive or negative. We will see if there is any transition, sign change, positive to negative, negative to positive. Number of sign changes equal to number of roots in the right hand side of S plane. So this is another numerical which is solved by me. Okay, so this is a very simple kind of thing. S raised to 4 plus s cube 20 s square 9s plus 100. So there are many numericals like this. So you are forming the table 120, 100, 190, and you are finding that the s term is minus 1 by 11. What is the value? Not important. Okay, whether it is positive or negative, that is important. So 11 to minus 1 by 11 is one sign change. Minus 1 by 11 to 100 is another sign change. So what is the conclusion? Conclusion में तुमको समझा के लिखना है. Just don't say that it's stable, it's unstable. No, you have to write that there are two sign changes in the first column. That is one from 11 to minus 1 by 11. Another sign change is minus 11 minus 1 by 11 to 100. So as there are two sign changes, it means that there are two poles which are lying in the right hand side of S plane. Hence the system is unstable. So there's another numerical, and now we are going to see there are two special cases. So these were very simple numericals. Now there are two special cases. Okay, and those numericals you have to remember. So question is sometimes asked is explain the special cases of RH criteria. Okay, so what are the special cases? We will see. While forming this table, we will find that the first column element or the pivot element in a row is 0. Okay, so as long as you are not solving the numerical, ये समझेगा नहीं. Whereas all other elements in the row are non-zero. Then how to find the RH case? So let us see what is the numerical. So this numerical you have to remember. If this theory is asked for 10 marks, you have to solve this numerical and explain that when we will get stuck. These two are special cases. That means we will get stuck, and then how to come out of it. So even if there is the first element as 0, because we are dividing, so bottom left multiplied by top right minus top left multiplied by bottom right divided by the first element. So this first element is called as a pivot element. If the pivot element becomes 0, then how to proceed? Okay. So in this case, let us take this numerical s to 5 plus 3 s to 4 plus 2s cube plus 6s square 6s and 9. This you have to remember, because in theory I may ask explain the first or with a numerical explain what will you do when the first pivot element in a RH criteria becomes equal to 0. So in that case I will not give you the numerical. In that case you have to remember this special case, and you have to explain this numerical with a special case. So if this is given, so you have to remember this equation: s to 5 plus 3 s to 4 plus 2s cube plus 6s square plus 6s plus 9. Only the coefficients you have to remember, otherwise you can find the thing. So what is the first s to 5 row? It is 1, 2 and 6. So 1, 2 and 6. What is the second row? 3, 6 and 9. So 3, 6 and 9 can be again written as 1, 2 and 3. So first row is 1, 2, 6, and second row s to 4 row is 1, 2, 3. So this is 1, 2, 1 multiplied by 2 minus 1 multiplied by 2 divided by 1. So you are finding that in S cube, the first element has become 0. And this is the very special case. This is the worst case, because in the next time you are not able to find out anything. Okay, because you have to divide then the things by 0. And dividing by 0 means it goes to infinity. Okay, infinity also should not be a part of RH criterion. So first element or pivot element for any row, if 0, then this is a special case. How to come out of it? So what we have to say is the first row is 1, 2, 6, the second row is 1, 2, 3. Actually it was 3, 6, 9, and it has become 1, 2, 3. If you are calculating s cube, the first element becomes 0. Other things, second element, that is 1 into 6 minus 1 into 3, that is 6 minus 3 by 1, this is equal to 3. Okay, so no problem in that. Second element is 3, so that is not a problem, but first element has become 0. If the first element becomes 0, whenever you are finding the next thing, it will be 0 into 2 minus 1 into 3 divided by 0. So it will go into infinity. So 0 into 2 minus 1 into 3. Okay, so that is not a problem. This will be minus 3 divided by 0. That means this s square first element will go to infinity. And all other thing in that case will become 0. Likewise, it will become. We don't want that. So what we do is whenever the first element or pivot element of any RH criteria becomes 0, the solution is replace it by a very small positive number, which is given by epsilon. So it is given here. Replace 0 by a very small positive number. Very small, how small? We don't know. So it may be 0.0000001. Okay. So 0 and 0.0000001 decimal is almost same. So whenever we are finding the first pivot element is equal to 0, the solution is we cannot proceed. The first element becomes 0 means we cannot proceed. In that case, we assume that the first element a very small number. Very small number means epsilon. And with that, we have to now proceed. So what is S4? S4 is 1, 2, 3. S cube is, previously it was 0 and 3. Instead, in place of 0, we have to assume a very small number which is called as epsilon. So now you assume epsilon and 3, and you now calculate what are the other elements going to be. So this is 1, 2, and this is epsilon 3. So this is 2 epsilon minus 3 divided by epsilon. So next row, this is 2 epsilon minus 3 divided by epsilon. Okay, and what is the next element? Epsilon into 3 minus 1 into 0 divided by epsilon. So this becomes 3. Okay, so one element is 2 epsilon minus 3 divided by epsilon. This is like this. Next element is 3 into epsilon minus 1 into 0 divided by epsilon. So this becomes 3. Okay, likewise. Okay, next what is there? Next is 2 epsilon minus 3 divided by epsilon into 3. Okay, likewise. So now it is s cube and s square. That will give us the value of s raised to 1. How to get it? So 2 epsilon minus 3 by epsilon. This first term multiplied by 3. That means 6 epsilon minus 18 by epsilon minus 3 epsilon divided by 2 epsilon minus 3 divided by epsilon. So this diagonal from bottom left to top right minus top left to bottom right divided by bottom left element. That is giving us s raised to 1 as 3 minus 3 epsilon square divided by 2 epsilon minus 3. Okay, and the last element is 3, because now it is 3 minus 3 epsilon square into divided by 2 epsilon minus 3 multiplied by 3 minus of this into 0 divided by this. So whatever is there in the s square right side column, the same 3 will come here. Okay, so as long as you are not solving it by your own hand, you will not be able to understand what is the difficulty level. Things are not difficult, but only thing is once or twice you have to practice by your own hand. Solve this numerical only. Okay, all the questions will be asked from this notes itself. So very simple arithmetic. It won't take more than 5 minutes to solve this. Now what we are supposed to find out, we have to analyze the stability of this Routh-Hurwitz criterion. Okay, so we are supposed to find out that whether this first column is positive or negative. Okay, but we don't know what is the value of epsilon. Okay, so epsilon value is very small. Epsilon value is very small positive. Okay, if we see that, you'll be finding that this s square, okay, this s square, the numerator can go negative, because 2 into epsilon minus 3. Okay, so 2 into epsilon value is very small. That means this part will definitely go negative. Okay, because epsilon value is very small. And this part is to 1. So 3 minus 3 epsilon square divided by 2 epsilon minus 3. Okay, this part can be negative, this part can be positive, doesn't matter, but this part will be very small. This part will be very small means 3 minus very small, this part will be positive. So just looking at it, what I can understand is the s square part will be negative. That means there will be a sign change and the system is going to be unstable. This is what my understanding is. Let's see what is the logic they are developing. The first element in the s square row. So we can see the first column. So in the first column, who are the trouble creators, who are the troublemakers, who can go negative or positive. So we don't know about these two terms. 2 epsilon minus 3 by epsilon. So divided by epsilon chhod do, because divided by epsilon is not deciding any part. 2 epsilon minus 3, whether that is positive or negative, that is the question. And second case, 3 epsilon square divided by 2 epsilon minus 3, whether it is greater than 3 or less than 3. These two are the question. What is the first question? 2 epsilon minus 3, whether it is positive or negative. If 2 epsilon minus 3 is negative, that means there is a sign change in the first column. That means system will become unstable. And second question is 3 epsilon square divided by 2 epsilon minus 3, whether it is greater than 3 or less than 3. If this part, second part is greater than 3 means this sign is also negative. Okay. So let us see what is the logic. The first element in the s square row, 2 epsilon minus 3 divided by epsilon, which has a negative sign, sigma tends to 0. So what you have to do is now in this two elements, so 2 epsilon minus 3 by epsilon, what you have to assume is sigma or epsilon tends to 0. Okay, if you are doing that epsilon tends to 0, what you will find is the numerator value is becoming minus 3. Numerator value is becoming minus 3. That means epsilon is very small, so that's what I told you in the starting. Epsilon value is very small. That means 2 into epsilon further small. Okay, and that very small thing minus 3. That means what is the net result? Almost equal to minus 3. That means this 2 epsilon minus 3 divided by epsilon is kind of a negative. Okay, that means there is sign change expected in the first column. What about the second term? That is 3 minus 3 epsilon square divided by 2 epsilon minus 3, and also if you are taking into epsilon tends to 0, you'll be finding that this value is plus 3. Okay, because if you just substitute in your mind only, you have to substitute epsilon is equal to 0. So denominator becomes minus 3 and numerator becomes 0. So 0 by minus 3, that is 0. So this part is just 1, it becomes 3. 3 is a positive number. So if you see, if you do epsilon tends to 0, what this first column becomes? It becomes 1, 1, then epsilon. Okay, this is also positive. Then it becomes minus 3. And then it becomes plus 3, and then it is 3. What is the first column becomes? 1, 1, epsilon, minus 3, plus 3, and plus 3. That means there are two sign changes from epsilon to minus 3 and from minus 3 to plus 3. So as there are two sign changes, that means there are two poles which are in the right hand side of S plane, hence the system is unstable. So that is what they have written. That is 2 epsilon minus 3 by epsilon, which has a negative sign, sigma tends to 0, and the first term 3 minus this has a limiting value of plus 3. So examining the terms in the first column of the Raut array, it is found that there are two changes in sign, which implies that there are two poles in the right hand side of S plane. So for the case where characteristic equation has imaginary axis roots, replacement of the zero pivot element. Pivot element is the first element in a row. Okay, if that goes 0, then it is problem, because you divide it by the first pivot element to get the next row element. Okay, so you cannot keep it as 0. In that case, the next row element becomes infinity. What is the solution? So you have to pose the problem first, because you have to remember this numerical equation. You have to pose the problem first, and then you have to give it solution. What is the solution? Instead of 0, assume a very small amount of positive value, which is given by epsilon. Make the whole table, make the first column, and finally substitute epsilon tends to 0, and then find out whether the values of first column are positive or negative, and accordingly you decide whether the system is stable or unstable. Another numerical you take, so all these things are given in the book of M. Gopal. So s raised to 6 plus s5, 3s4, 3s cube, 3s squared, 2s and 1. So you're finding 1, 3, 3, 1, because 1, 3, 3 and 1, that is the even polynomial. Yes?
Sir, I have a doubt, sir.
Yes?
In the term 2 epsilon minus 3 by epsilon, when it tends to 0, then divided by 0 it will come out, sir. Why won't it be infinity?
No, again, you are mistaken. See, denominator does not decide whether the value is going to be it is infinity, ठीक है, but it is positive infinity or negative infinity.
Negative infinity.
So that is negative, right?
Okay, okay, okay.
So that's why you have to do a very simple analysis that who is deciding for the symbol. Denominator is not deciding for the symbol. Denominator is deciding for the value, because epsilon is positive. So denominator is positive. So वो छोड़ दो. We want only sign. We want only the symbol. How much is the value? Irrespective. So who is deciding the symbol or who is deciding the sign? 2 epsilon minus 3. Epsilon tends to 0. 2 epsilon minus 3 tends to negative. Understandable?
Yes, sir.
Okay, that means there is a negative sign in the first column. So value is not important. Even if it is minus zero point 0.1 or even if it is minus infinity, both are negative. So in that case, there will be a sign change. And next term is again becoming positive. Next term is again becoming positive. So from epsilon to negative and from negative to positive, there are two sign changes. Hence, there are two poles which are in the right hand side of S plane. Hence, the system is unstable. Okay.
Yes, sir.
Okay, so can I see this next numerical? ये और भी complex हो गया देखो. So 1331 and 132 and all. So if we are just solving, so this is 3 minus 3. So first term becomes 0. As soon as the first term becomes 0, we have to replace it by a epsilon. So this first term is epsilon, next term is 1, next term is 1. So 3 epsilon minus 1 divided by epsilon. So in case of 0, you have to write a epsilon. So that they have forgotten. So in case of 0, you have to write epsilon. So epsilon into 3 minus 1 divided by epsilon. This is the first term. Second term is 2 epsilon minus 1 by this, and likewise you just keep on doing. Now is the real problem. Okay, so if this epsilon is very small, can you tell me what is SQ first term? This term again becomes negative. Is it understandable, Vinay? 3 epsilon minus 1. Okay, epsilon value is very very small. तुम 0.00000001 ले लो. That means 3 into 0.00000001. It is much less than 1. So the first term is negative. Is this understandable? 3 epsilon minus 1 नीचे लिखा भी रहेगा वो लोग. Okay, so they have given the logic somewhere. They have written. So you have to just say that if epsilon tends to 0, at that time this 3 epsilon tends to 0. In that case, this term is going to be negative. That means 1 to negative, एक sign change to minimum है. That means the system is unstable. So as epsilon tends to 0, the elements of s raised to 1 row tends to 0. So that is what they have said. If epsilon tends to 0, then the elements of s raised to 1 row tends to 0. That means s raised to 1 में numerator में 4 sigma square, sorry, 4 epsilon square minus epsilon. That means 4 into 0 minus 0. That means this is 0. Okay, so this indicates the possibility of existence of imaginary access roots in the S-plane. We therefore need to examine the auxiliary polynomial. But in this case, what I find is 3 epsilon minus 1 divided by epsilon. This itself is going to be negative. Then the system is unstable. So what we are finding like this. So eventually, वो आता रहेगा. There are two sign changes in the first column of the array. This indicates that there are two roots in the right half of S-plane, and there's this, and system is unstable. So likewise, so there's a big numerical anyways. So as s raised to 1 term is becoming 0, as s raised to 1 term is becoming 0, here also another small value of epsilon 1 you have to assume. Okay, and then with that again you are finding what is the other thing. So there also they have assumed another epsilon. Okay, and this is 1 and this is 2 epsilon minus 1. So this is again negative. Okay, this is again negative because 2 epsilon minus 1 by epsilon. So 2 epsilon minus 1 for epsilon tends to 0. This is again negative. That means there are many negatives in the first column. So very easily you can say that the system is going to be a unstable system. So that was the first first special case where the first element in a row is becoming equal to 0. Let us go for the second special case. Actually, this I have mentioned as special case. The second one I have mentioned as 1. So this is special case 1. I'm sorry. The second one should be special case 2. So it's my mistake. I will upload this corrected document only. This is called the special case 2, and this is handwritten by me, so it will be easier to understand. Just see what is the problem. Or this is also 1. Okay, this is also 1. This is a continuation of that, only my handwritten note. I'm sorry. This is the same thing. Not a problem. So on a special numerical given by me, so this is s to 5 plus s to 4 and all. You're finding that s square element is becoming 0. So in that case, s square element you have to assume as epsilon, and then you have to do the cross multiplication and all, and you are finding s to 1 element is coming to be minus 12 by epsilon. Okay, and if epsilon is tends to 0, you are finding this whole element is going to negative infinity. Negative infinity is not important thing, but negative value is important. So what you are finding is there are two sign changes. There is first column elements are 1 to 1 epsilon minus 12 by epsilon plus 6. As there are two sign changes, system is unstable. So this logic is very important. So don't just say stable or unstable. In that case, you are not going to get any mark. Don't play trick with the examiner. Never. I think in your IA1 paper, many of you have done that trick in true, false and all. So don't play trick. Here, very simply you answer whether it is stable or unstable and why it is stable and why it is unstable. That logic you have to give very clearly. Okay, so this was the type 1 case. Type 2 case, this is again same thing. The whole row becomes equal to 0. Okay, so a complete row appears to be 0. Then how to go for RA stability analysis? This is little complex. So what is the equation? S is to 5, S is to 4, 4s cube, 24s square, 3s and 63. If you're seeing that this is 1, 4 and 3, this is the first column, first row, and second row is 1, 24 and 63. Okay, so if you're just solving it, it becomes minus 1, and so it becomes minus 20 and minus 60. Okay, and in that case it become minus 20 minus 60 means minus 1 and minus 3, or you can say as 1 and 3 also, it doesn't matter. Okay, then what if you are solving the s square is becoming 1 and 3. Okay, and then if you're solving, so this is minus 1 minus 3, that means 1 3, and this is also 1 3, you will find that s raised to 1 row completely becomes equal to 0. So what was the special case 1? Special case 1, the first element was becoming 0. Okay, how did we solve it? Just take the first element as epsilon and proceed. Do the whole table, then check the first column, and there whatever you are getting accordingly plus minus, you have to say that whether system is stable or unstable. But in this case, the special numerical you have to remember, you are finding that the whole row is becoming 0. So s raised to 1, this whole row is becoming 0. Then what you have to do? So the special numerical case you have to remember 143, then 1 24 63, s cube. S cube become minus 1 minus 3 or 1 3, same thing. A square. So s cube and s square both are becoming of same element. So whenever you are trying to find out s is to 1, that is 1 into minus 3 minus of minus 1 into 3 divided by 1. So it will be 0. And next element 1 0 and minus 1 0 divided by 1. So this is also becoming 0. Whenever the whole thing is becoming 0, how to go for that? How to solve it? Okay. So in this case, you have to go to the previous row. Whenever you are finding that s is to 1 is becoming 0, you have to go to the s square row. What is the s square row? What is the first coefficient? It is 1. What is the second coefficient? It is 3. So write the polynomial. What is the polynomial? It is s square plus 3. So whichever row is becoming 0, uske pichla wala, uska upper wala row mein chale jao. Okay, what is the upper, and write that polynomial and differentiate it with respect to s. ये सुनने में बहुत बड़ा लग रहा है, but when you practice, it becomes very easy for you.
Sir,
And
if
students, very easy. Yes,
sir, if suppose now square row में 0 0 रहा, then
स्क्वायर में 0 0 रहा तो तुमको उसके ऊपर एस क्यूब में जाना है. सो माइनस एस क्यूब प्लस 3s इज इक्वल टू 0.
plus 3s is equal to 0. Okay.
अंडरस्टैंडेबल. सपोज एस स्क्वायर रो में पूरा 0 है, देन यू हैव टू टेक माइनस एस क्यूब माइनस 3s इज इक्वल टू 0. दैट मींस एस क्यूब प्लस 3s इज इक्वल टू 0. दैट मींस एस स्क्वायर प्लस 3 इज इक्वल टू 0. अंडरस्टैंडेबल.
Yes, sir.
Minus s cube minus 3s, because this is odd polynomial, because s cube is odd polynomial. So minus 3 s cube, sorry, minus s cube minus 3s equal to 0. So s निकाल दो और minus भी निकाल दो. That means s square plus 3 is equal to 0. Okay, and then you differentiate it. Differentiate, that means 2s equal to 0. So that 2s will come in the next. Solve करने दो मुझे, you will understand. So here s raised to 1 part has become 0. That's what I have to go to the previous stage. Previous step is s square polynomial. So this is s square plus 3. अभी देखो next step में क्या किया है. Okay, so what they have done is s square plus 3. Okay, so s square plus 3 go, what you can do is solving the auxiliary equation s square plus 3 is equal to 0. We get the roots as s is equal to plus minus j root 3. Okay, so what we have substituted is minus 20 and 0. ये कहाँ से आ गया? So s cube plus s square plus s plus 21. In order to examine the remaining roots, what we are doing is divided by as. ये थोड़ा they have made it complex. Okay, so they have made it complex. So this numerical I'm not going to explain like this. uh, Check this numerical. Okay, so this 5.4 you don't see first, because they have proceeded by a different process, and you go by my method. So my numerical is also given below. You check the second numerical. Okay, this will give you the a better idea. If one row becomes 0, so here you find s to 6 plus 2s5 plus 8s4 12s cube. ये equation याद रखना है. With respect to this equation you have to explain. So what is this 1? So this is s to 6 ka 1, 8s to 4 ka 8, then this is 20s square, this is 20, and this is 16. Okay, so give me 5 more minutes, I'll finish it off. So this is 2s to 5, so this is 2, then 12, then 16, and 0. So if you just cancel this 2, 12, and 16, you are finding 1, 6, and 8. Likewise, and then s to 4 again 1 6 and 8. So s to 5 is 168, s to 4 is also 168. S cube you are finding as 0 0. So if you are finding s cube as 0 0, when I was just now asking, you go to s to 4 level. So s to 4 means this is s to 4 plus 6s square plus 8. अभी समझ में आ रहा है what is as? Just you have to go to the previous row. Whichever row is becoming 0, you have to go to the previous to that row. So this is s to 4 plus 6s square plus 8 is equal to 0, and you differentiate it by s. So 4s cube plus 12, 12s it should be. Okay, so this will be 4s cube plus 12s. So in this s cube, what you can write is 4s cube and 12s. That means this s cube row will be 4 and 12. So अभी देखो, in the next it will come s cube में it will come, previously it was 0 0, now it will become 4 and 12. अभी समझ में आया?
Yes, sir.
Other two persons. So यहाँ पे एक मिस्टेक भी है इन लोगों का. Whenever this 2 has become 0 0, you have to go to the previous row. Previous row is s raised to 4, that is s raised to 4 plus 6s square plus 8. Okay, if you differentiate it with respect to s, this will be 4s cube plus 12. 12 नहीं है, ये 12s है, because 6s square का differentiation with respect to s. So this is 12s it should be. Okay, so 4s cube plus 12s. That means this s cube, previously it was 0 0, now it will be substituted with 4 and 12. So previously whatever was there, it will be there, and s cube will become now 4 and 12. So that is what has been written here. So now it is 4 and 12, and then they have proceeded. So ये 4 and 12 कहाँ से आ गया? Go to this. This s cube has become 0. So now you have go to the previous thing that they have said. यहाँ पे भी ये 12 भी लिखा है, but this should be 12s. Okay, so go to the previous. S is to 4 plus 6 square plus 8. Differentiate with respect to s. This is 4s cube plus 12s. So this you write as coefficients of s cube row. So this is 4 and 12. 4 and 12 means 1 and 3. Okay, now previous row it was 1 and 6, and now it is 1 and 3. So 1 into 6 minus, so 6 minus 3 by 3, that is equal to 1 by 3. Okay, so this is 6 minus 3, that is 3, and 3 divided by 1, so that is equal to 3. And again this 1 into 8 minus 1 into 0 by 1, so this is equal to 8. So this 3 by 8, this is a square. What is the next line? Next line is 3 into 3, sorry, this is 1 by 3 into 8 minus 3 into 0 by 1 by 3, so that is equal to 8. So likewise, and we are finding that all the first column elements, they are all positive. That means the system is stable. Okay, so this is a big thing. Marginally stable they are found because there are some more conditions, but you can say it is stable. This is the last numerical we are discussing, that is s raised to 6 plus 2s5 plus 8s raised to 4, 12s square, s cube, likewise. So if you are doing it 1, 8, 20, 16, that is the even polynomial, 2, 12, 16 is the odd polynomial. You are finding that s raised to 4 is becoming 2, 12, 16, and s cube has become all 0. As s cube is becoming all 0, then you have to go to s raised to 4. So 2s raised to 4 plus 12s square plus 16, that is equal to 0. Then DAS of DS. So if you are doing it, this is 8s cube plus 24s, like this. So what will be now s cube element? S cube element will be 8 and 24. So you are finding the same thing. That is s raised to 4 was 2, 12 and 16. You can check here. Previous case, s raised to 4 element. So s raised to 4 element is 2, 12 and 16, and s cube element will be 8 and 24. You are finding it like this. So s raised to 4 element is 2, 12 and 16, and s cube element is 8 and 24. Now again you have to just keep on calculating, and you are finding this. Other elements as 6, 16, 0, 2.670 and 16. So now you have to check the whole first column. Whole first column means previously s raised to 6, that was 1, s raised to 5, that was 2, s raised to 4, that was 2. Then after this adjustments, you are finding s cube as 8, s square as 6, s as 2.67, and s as to 0. S as to 0 somebody writes as 1, but you write s as to 0. So that is 16. So as there are no sign change in the first column of RH table, given PS. What is the PS? PS is nothing but the given polynomial. And what is this given polynomial? This given polynomial is nothing but the characteristic equation of a closed loop transfer function. So by this method, we are trying to find out whether a closed loop transfer function is having poles in the left hand side or in the right hand side. So after this RH criterion, in the second special case, we are finding that there is no sign change in the first column. That means all the roots are lying in the left hand side of S plane. That means the whole system is perfectly stable. So I end here this lecture. I end here module 3, and 2 questions can be asked from it. One is any kind of numerical. So there are 3 types of numerical. One is very simple numerical, and second one is 2 special cases. In 2 special cases, one is the first element will become 0, and second one is the whole row is becoming 0. If first element is becoming 0, take epsilon, proceed. Finally substitute epsilon tends to 0 and find out which is going to be positive, negative. Second case, the whole row might become 0. Whenever the whole row is becoming 0, you go to the previous row, differentiate it with respect to s, get the coefficients and plug in the next row which were becoming 0 previously, and then you proceed with the same RH criterion. So two questions can be asked, two types of questions can be asked. First type is I can ask you numerical. Okay, so I can ask you give you a PS, and I can ask you find whether the system is stable or unstable. So the numerical can be of 5 marks, 10 marks depending on its size. Second question, which is a theory question, but it is little preparation is required. I can ask you explain with numerical the two special cases of RH criteria. So for that you have to remember the polynomial, one for the first element becoming 0 and one for the whole row becoming 0. So you have to solve actually two numerical in that case, and you have to tell what is the problem, how to solve the problem, and how to find the stability from RH criteria. So these are the two questions